The next section of Chapter 11 is mathematical induction. The purpose of mathematical induction is to prove that a formula for a sequence or a series works. That's the point of it. So this is how you start. Here is our sequence. This is the formula to get to the next term. And if we were to do the sum of them, this would be the summation formula. So we are proving that this indeed works, that this formula, given this end term, will add up to 2n squared. You first have to plug in 1 for both sides. So 4 times 1 minus 2. Plug 1 in for the first term. We do get 2. Plug 1 in for the summation formula, the one that's on the right side, and we do get 2 again. As long as they check out, we can move forward. So this is what you're going to do. We're going to start off first with what the summation equals now, this piece right here. So I'm going to start off with 2n squared. I'm going to add another term to it. Not the 4n minus 2, but I'm going to add 4n plus 1 minus 2. I'm going to add another term to it. What this should equal then is a new summation formula with n plus 1s. Sorry that it's sideways. Okay, that's how it goes. You start with your summation, add whatever formula they gave you for the nth term, add another term, so an n plus 1 to it, and that should equal the summation formula, but for the next term, which is n plus 1s. And then now we just have to prove that the right side and left side are equal. So we're just going to keep going with our math. You know, distribute. I'll keep going with this side. 2n squared plus 4n plus 2. On the other side, we have n plus 1 squared, so that's FOIL, n squared plus 2n plus 1, and then distribute it 2n. As long as the two sides match, we just proved that that indeed is true. Oh, hey, you might want to star. This is on the final exam. Usually induction is. I don't know what I told you. Sequences and series. I don't go too in-depth on the final exam with arithmetic or geometric sequences. Maybe one summation question might be on it. So you might want to have all your information on your 8.5 by 11 sheet, but there's not a ton of questions on that stuff on the final exam. But onward we go. All right, so here we have the next one. Here's our sequence. This is the nth term, and then this is what the sum formula is. So I first have to start with 1, plug 1 into the nth term. We get 3, which is true because 3 is the first term. Then 3 times 1, 1 plus 1, all divided by 2. Well, on the top we get 3 times 2, which is 6. 6 divided by 2 is still 3. So we can move forward. All right, so we start with our summation formula right now, as it is. We are going to add the next term. Oh. One too many parentheses. And that should equal, oh, this is over 2, a new summation formula with n plus 1s. So working on the left side, we get 3n squared plus 3n over 2 plus 3n plus 3. On the right side, I'll distribute my first 3n in. 3n plus 3 in the second parentheses, n plus 2. On the left side, I need a common denominator of 2. See, we get plus 6n plus 6. And on this side is going to be a FOIL, 3n squared plus 9n plus 6. I just need to simplify the left side. and they are equal, which means that this does work. The last one for the front. Here's our sequences. Here's the nth term. Here's our formula. So plug 1 in. And we get 0. Plug 1 into the other one. And we still get 0. Okay, so we can move forward. I'm going to change my pen so it's thinner. How do we first start with our formula now? We are going to add this, but being the next term. And it should be our summation formula just with the next term. N cubed minus n over 3, n squared plus n. So this side becomes n cubed plus 3n squared plus 2n all over 3. My right side becomes out to be n cubed 3n squared plus 3n plus 1 minus n minus 1. Sorry that I went down. Which comes out to be the same exact thing as the other side. All right. I'm going to skip this one. I mean, it's the same process again. Just, keep doing it. Plug in 1 first. There and there. Then summation formula plus nth term with n plus 1s should equal summation formula with n plus 1s. All right, now these are a little different. It says, is 2n less than 2 to the n for all n greater than or equal to 3? Well, what we first are going to do is plug in the first term. Now, it gives us a condition. We have to be greater than or equal to 3, so we're going to plug 3 in. Well, this side is 6, this side is 8, so yes, that's true. Now we're going to plug n plus 1s in. So this side is 2n plus 2. This side, I can split this up as 2 times 2 to the n. Right, this is a first, that's an n. Which means I can factor a 2 out of this side. And these 2's go away. Now I have n plus 1 is less than 2 to the n. Multiplying a number by 2 is greater than adding it by 2, which is true. So yes. All right, so now we have a condition of 100. Oh, 1 too many zeros. This is 1, 2, 3, 4. They're equal. So now I'm going to plug n plus 1s in. So you get 100 n plus 100. n squared plus 2n plus 1. Now we are already assuming this part is true. Okay, so we're already assuming that that is true. So I'm going to take that piece out. Take this out, and it's that out. So now we have to decide if that's true. Well, I'm starting with n being 100. So is 100 less than or equal to 2 times 100 plus 1? Yes, that is always true. So if using n is greater than or equal to 100, then it is true. These sum of power formulas, they come up again in chapter 12 as well. I think you might need to know them. I'm not really sure. Right now, but they do come up again.